Welcome student. Today we will study the topic X-ray diffraction analysis. First of all, we should understand what is X-ray. So, for your information, X-ray is high energy electromagnetic radiation which is similar to light but having its wavelength ranging from zero point 0.1 to 10 nanometer. And now the second term, diffraction. You should understand what is diffraction too. So, in diffraction, when parallel waves of light are obstructed by a small object, that is corner, edge, sharp, slit, etc., then waves spread beyond the edge of obstruction and interfere, resulting in dark and light patterns. So now we should understand what is X-ray diffraction in a whole. X-ray diffraction is a technique to study crystalline structure of a sample. The sample present in the powdered form. Now the sample is in the form of crystals. The crystal have the regular arrangements of atom, and as you show in this diagram that the crystals have uh, arrangement of patterns of atom at regularly spaced point. So when we enlarge this, we see that this is a atom, and which contain nucleus in the center, and electrons are rotating around the nucleus. So X-ray is high energy light. This is X-ray. These are X-rays. This is of high energy light. And when we enlarge this high energy ray, then we can saw this type of pattern. So this from here to here, this is a wavelength. So X-ray consists of repeating unit of wavelength, and this wavelength of X-ray is similar to this the wavelength of X-ray this wavelength of X-ray is similar to distance between the atoms in the crystals. You see, these are atoms in the crystals. And when this X-ray hit the atoms of the crystal, diffract, and thus we can say or conclude that crystal act as a natural grating. And crystal as well as X-ray have dimension in the order of 10 to the power minus 10 meter. X-ray shows property of both electromagnetic. So the electrical component of the X-ray when hit this electron of an atom, the electron oscillates in its position. This these electrons oscillate in its position. Thereby generate electrical field, and emits X-ray in random direction and emit rays in random direction, and this phenomenon is known as Thomson scattering. So, why we should study X-ray diffraction? We study X-ray diffraction to know the structure of an atom. X-ray diffraction by crystal is a reflection of periodicity of the crystal. We can say like this. So now I will explain in detail how we do X-ray diffraction analysis. So in X-ray diffraction analysis, first of all, the sample is placed in the center of the instrument. This is instrument, and this instrument is known as this instrument this instrument is known as goniometer, and when illuminated with the help of X-ray. So in goniometer instrument, what happens? This X-ray tube and detector. This is detector is moved in both this X-ray and detector are moved in synchronized motion. Thus, when X-ray tube uh, emit or focus X-ray on the sample, then there is emission of signal from this sample, and this signal are recorded on the graph, and this graph in this upside there is intensity, and this side 2, 2d theta signal is recorded, and the signals are recorded in the form of peaks. First signal will have large peak, then second will have relatively smaller, and in this way peaks diminishes. So this X-ray diffraction was discovered by two scientists, that is Sir William Henry Bragg, uh, he father, and William Lawrence Bragg, who was son, and they won Nobel Prize for studying crystal structure by X-ray diffraction method. And as I have already mentioned, what is crystal? Crystals are regular arrangement of atomic arrangement of atoms in a unit cell. Okay, and in unit cell are composed of 6 parameters, and these in which 3 are of axis and 3 are interaxial angles. 3 axes are A, B, C, and interaxial angles are alpha, beta, and gamma. And in cubic system, the axis, that is A, is equal to B equal to C, and interaxial angles, that is alpha, beta, and gamma, is 90 degree. Within crystalline lattice, there is infinite set of regularly spaced planes, which is drawn through lattice point. And in primitive type of cell, the lattice point is present in the center, and the lattice point is only one present in the center, and these planes are considered as the source of diffraction and are denoted by Miller indices. So uh, so these are these are regularly spaced atoms in the crystals. What happen? And these are these are planes of these are planes of atom denoted by HKL for the first plane, and second plane also show the Miller indices HKL, and the interplanar difference is D. This interplanar difference is D. So what happens when when X-ray hit this atom, when X-ray hit this atom, it reflect the ray of beam at particular angle. Suppose the angle is theta. The angle is theta, and and uh, and then this when this when the second ray hit this atom just beneath this, then it also reflect the ray. So we have to for diffraction to occur, for diffraction to occur, there must be constructive and destructive interference. So first of all, we should know what is constructive interference. Yeah, as I have already know that X-ray ray is composed of repeating units known as wavelength, and this wavelength is composed of crest and trough. This is crest and trough. When the uh, crest portion, when crest portion, this crest and crest ye coincide, then the wave join to form constructive interference. While suppose when when the crest overlaps with trough, then there is formation of destructive interference. So in constructive interference there is uh, bright pattern shown, and in destructive interference there is light pattern shown. So for uh, for for constructive interference, to study constructive interference, we may measure diffraction by path difference is equal to n lambda. And for this ray of light, the path difference will be, suppose this is A, this is C, this is B, and this is D. So for this point, path difference to be travel should be is equal to n lambda, and this for this AC plus BC is equal to n lambda. And to calculate AC, how we calculate AC? The distance between there is right angle, for this is right angle, this is 90 degree. So when we minus 90 minus theta, then this is when we minus 90 minus theta, then this angle is 90 minus theta. So from angle ADC makes angle theta. So this this is also theta. So from here we can calculate, suppose this is made like this ADC. So in this sine theta will be AC by CD. So sine theta is equal to, this angle is D, is equal to AC by D, and AC is equal to D sine theta. Similarly, BC is equal to also D sine theta. So putting in equation 2, we will get D sine theta plus D sine theta is equal to 2D sine theta is equal to n lambda. And so Bragg's law is calculated. And show order of reflection, and order of reflection, that is n, is inversely proportional to intensity of the light, wavelength of the light. So the first wave will have higher intensity, then second will lower. In this way the intensity will decrease. So final conclusion is that the sample, so what we have studied in this chapter or in this topic, that That sample is made up of crystals, and for example, crystals may be like sugar crystal, sand crystal, mineral crystal. And to study these types of crystal in the form of unit cell, we use X-ray diffraction. And the when monochromatic X-ray, when focused on crystal, produces constructive interference, and this is measured by Bragg's law, and which is characterized in form of their crystal structure. And this is the end of the topic. Thank you.